Welcome to the Continuum Lab. I'm Jeppe and this is KontrolFreak. I make a new MIDI controller in every video. I make it up as I go along using scraps that I have lying around, and then I jam for a bit and record another voice for the KontrolFreak theme song, which is what's playing right now. This is my MIDI Melodica. It was made by installing a breath sensor into the keyboard that I made in an earlier episode of KontrolFreak. This video is all about how I made it, so let's go. A melodica is basically like a small piano keyboard with a couple of octaves that you can hold in your hands and then play the keys, and then there's a tube attached to it that you put in your mouth and blow, which controls the volume. And so I'm going to make an electronic version of this as in a MIDI controller, and of course I'm going to recycle this instrument here that I made a couple of videos back, which will make the whole project much easier. It already has the electronics inside to read all of these 16 keys, and so I just need to reconnect the TNC breakout board. Of course, the TNC breakout board is currently inside my drum kit, and so I'll have to disconnect everything here. So if you saw the video that I made about this keyboard, then you will know that it's quite easy to figure out where to plug this in. And we're done. I could now re-upload the code for the monophonic keyboard that I made a couple of videos back, and this would work exactly as it did in that video. But for this project I'm going to expand this keyboard with a breath sensor. And when I say breath sensor, I'm not talking about an industrial breath sensor that you buy, which is made for this kind of stuff. No. I'm going to make a breath sensor from scratch, basically from simple components and some scrap materials. And so I've assembled some things that I think would be useful for that purpose. So there's a hot glue gun, some cardboard. Then there's the components. I have a 3mm blue LED. Then there's two resistors. I have a 47K resistor and a 220 ohm resistor. Then there's a tiny PIN photodiode. This is basically like a very small solar cell. Then I have a couple of rubber bands of different sizes because I don't know exactly what I will need. Then there's a black balloon, regular toy balloon. Then there's this length of silicone tubing here. I think it's 8mm external diameter and 5mm internal. This is a food grade item, which is normal for silicone tubes, but this one specifically is food grade. And then finally there's this weird little cup here. This is a measuring and drinking cup from a bottle of mouthwash, and so this is also food grade. So the common theme here with the food grade materials is because these materials are going to be in direct contact with your breath and your saliva and so on, and so it's important that they be food grade because you wouldn't want to poison yourself with any old 3D printed plastic or anything like that. So today's project is really special to me and close to my heart because I will be showing you the secret sauce, so to speak, that goes into the mouthpiece and breath sensor of the open horn MIDI system, which is this instrument here, which is my main project here in the Continuum Lab. This also uses a piece of balloon as a membrane. It uses food grade silicone tubing, and it uses the same basic components as we're going to use today, namely the LED and the photodiode. Using these super cheap and simple components, we're going to make a very high sensitivity, very high responsiveness breath sensor. So let's get started. First of all, we need to figure out how we're going to fit a breath sensor in here. Given that breath sensors are inherently wet, we need to make sure that we can keep the other components dry while still having the breath sensor here inside. So in order to make this breath sensor, the first thing we need is a pressure chamber, and that's what this cup is for. I think we can fit the cup nicely in here, but then we need to trim off a little bit to make it fit the way I want. Perfect. Now we need to make an entry hole for the silicone tubing. So the best way to make a perfectly round hole, which will make a nice seal around the silicone tubing, is to melt it. That was ridiculous. I made the hole too big on the first go. But I have a fix for that. A piece of larger silicone tube with a thin wall, which I think will fit over this. Yes. And then inside here. Okay, this is silly. Now it's too small. Let's have another go. Perfect hermetic seal. Sweet. That fits right in here, no problem at all, with almost a centimeter to spare. So that's perfect. Now I need to run the tube in from somewhere. I will be holding the Melodica like this. And so I'd like the tube to come up here. What we need to do now is add a membrane to this pressure chamber here, and that's where the balloon comes in. So the best way to turn this into a membrane for the pressure chamber is not to cut out a patch roughly of this size and then try to stick it on there with the rubber band. Believe me, I've tried. Instead, you need to just cut off a little bit of the balloon like this, and then you can stretch it out like this and sneak the whole cup into it. With plenty of extra material left over on all sides. Then you take your rubber band and just apply it like this. Let's see how that works. So the problem right now, of course, is that I blow into the tube, but then there's nowhere for the air to escape, and so I have to let it back out through my mouth to reduce the pressure. Of course, that's not how a wind instrument really works. So there's basically two ways to solve this problem. The simplest way would be to just cut a small hole, smaller than the inner diameter of the tube, somewhere along the tube, and then part of the air you blow in would escape through there. But that can also mess with the airflow somewhat, and so that's not my preferred solution. The other solution that I'm going to try is to make a second hole here and draw out a smaller diameter tube for the air to escape through, and then punch that out through the bottom of the instrument. So that's what I'm going to do right now. What could go wrong? I've done it again. This hole is also too big, so once again I will have to improvise. So luckily I have a whole bunch of different silicone tubes, and so it turns out that I have one which is the same thickness as the big one here on the outside, but with a smaller inner diameter equivalent to the same one that I had right here. So if I can fit this tube in the escape hole, that should also work. Oh, I cannot believe how badly this is going. I made it too big again. I'm going to have to do the same thing that I did for this one with the extra bit of tube on the outside. I'll make this work. It works. That was pretty crazy, but it worked out in the end. Sweet. Check that out. So depending on how hard I blow, I get an expansion of this membrane from nothing up to around 3 or 4 millimeters. Also, it is super fast and responsive. Okay, so that's the breath sensor, pressure chamber and membrane all taken care of. Now we need some electronics. So I'm going to run through this kind of fast because this is KontrolFreak. The basic concept is as follows. You have an LED shining its light from one side of the membrane here, and then on the other side you have the photodiode capturing that light. So then when you blow into the tube and the membrane expands, the light from the LED is gradually blocked, and so the reading from the photodiode gradually changes. So what we need right now is a physical structure of sorts that will surround the pressure chamber and which can hold these two components at this height. And then of course afterwards we'll have to connect the components, but we'll get to that. First of all, this structure I think could very aptly be made from cardboard. So okay, then we need these two situated here opposite each other. I'm just going to cut out a little notch like that. And fold this down and make sure that the top of that is flush with the membrane here. And then we do another one exactly the same here opposite. Fold that down. And so these are going to be the supports for our LED and our photodiode. So the next thing is to connect the components. So let's start with the LED. This is super simple. I'm running this off the 3-volt rail on the Teensy, and I'm just going to connect it via a 220 ohm resistor. Let's get my trusty soldering iron. And maybe I should plug that in. So while the soldering iron heats up, I can just quickly explain to you how I connect this other component here, the So while the soldering iron heats up, I can just quickly explain to you how I connect this other component, the BPW34 photodiode. This is a 2-pin component, and so to recognize the 2 pins, you look at the top of the component, where on one side, this side here, you will find a little dot. So from the side here that has the dot, we connect a cable directly to an analog pin on the Teensy, and then from that cable we also connect a resistor to ground. I'm using a 47 kilo ohm resistor. And then from the pin on the other side of the component, we run a cable directly to 3 volts. So as usual on these projects, I try to make the sensor end of these connections as simple as possible, so that I can run just 2 cables, and then down here at the other end where I will connect things to the microcontroller, I can put on the resistors and make things a little bit more complex. Done. The LED, a connector to 3 volts and ground. And there, that's the connector for the sensor. Okay, so let's see if we can fit it all together inside the box. Oh, almost forgot, I need a second hole here in the side for the escape tube. Okay, we're getting there, although, again, this is pretty crazy. I want to just test one thing. Plug the Teensy in here for a second. Indeed, the LED is working perfectly. I'm going to try to connect the LED on this side. Perfect. And this, of course, is where the hot glue gun comes into play. Let me just plug that in. Unplug that. So all that's really left to do now is to close up this box and try to take care that these cables here don't bother the new sensor, something like that. And then bring this over to the computer, put some code in it and see if I can make it work, and we can make some noise. Okay, let's plug this guy into the computer. I just want to show you something real quick. See how that works? The LED here is shining a light across the surface of that balloon membrane, and when I blow, the membrane expands and casts a shadow on the sensor, which is at the other side of the balloon. Cool, so that seems to be working perfectly. As usual here in the KontrolFreak, I have cheated a little bit and prepared all the code for the MIDI Melodica beforehand, just so you don't have to sit and watch me fumble through relatively simple coding concepts. However, I have, as always, saved a few files along the way so that I can show you the steps that I went through to make this thing work. So let's have a look at that. The first bit of code that I wrote for the MIDI Melodica is just a test of the breath sensor inside here. So it's a simple file that just defines what pin the sensor is on, then starts the serial, and then it reads the analog reading off of the pin that the sensor is connected to. So let's just try and upload that. Good, so let's try to open the serial monitor. And as you can see, we're getting a reading here of around 260 or 70 or so. So the moment of truth, let's see if we get getting a reading from our analog sensor here. We are indeed getting a reading, and it's let's call it a reversed reading, where we have a high number when I do not activate the sensor, and then it lowers and approximates 0 as I actuate the sensor. So this is quite interesting. That's of course because we have a light constantly falling on the sensor until I block that light and reduce the reading to almost 0. Anyway, so this is kind of a jittery and unstable reading, and so we're going to have to introduce some filters to make it more stable so that we can have a nice MIDI output. So that brings me to the next file. Let's have a look at it. So here in the second file, as I mentioned, I introduced these functions that are necessary for the filter. This is the exponential filter function, which I also used in the previous videos. And then here in the main loop, I do a few new things. First of all, I keep track of the previous reading in this value here, last breath raw. Then I analog read that same pin as before, but then I run that reading through the exponential filter to stabilize it. Then I map the reading to a suitable MIDI range, and then I limit it within the MIDI range, and then I check if there is a change in the reading from last time, and only if there's a change do I write to serial. So let's try and upload that. Okay, let's open the serial monitor. So as you can see, there is absolutely no reading right now, but that's of course because, as I just mentioned, we only write to serial when there's a new value. So let's try the sensor again and see if we can make that happen. That works beautifully. The reading seems quite stable. As you can see, the numbers flow up and down without jumping back and forth, which is nice. Okay, that works very nicely. Let's have a look at the next file. So as normally happens here in KontrolFreak, this is the file where all of the things that have to do with MIDI are introduced. But in this case, it's also where I reintroduce a lot of the code that I originally used for this when it was just a monophonic keyboard. It would be a complete waste of time to rewrite all of that code, so I've simply dug up the old file and copy and pasted a lot of this stuff over. So for example, the multiplexer is defined in the same way. My sensor array here is the pins that the keys are on. All of that is exactly the same because nothing has changed within the circuit or the physical structure of this instrument except to add an extra sensor. So if anything, the section in here that has to do with reading the keys has actually been simplified somewhat, because in the monophonic keyboard before I needed to keep track of what keys were currently active, but I don't really need to do that here. So it's a little bit simpler. But anyway, if you want to know exactly how this keyboard works, you should have a look at the first video in this series, and that's where I explain all about that. But the rest of the main loop here, which is all the code that reads the breath sensor, is the same as I just showed you before, up until here the serial print, which is still included just so I can troubleshoot the code. Now includes these functions here, which check if there's a change in the reading from the breath sensor, and then sends a USB signal. In this case, it's an all notes off signal, so that when the breath sensor goes to 0, all of the notes are turned on, no matter what keys you're pressing. And down here is the note on signal, as activated by the velocity. As soon as this one is activated, it goes from a 0 state to a non-zero state. Then we loop through all of the keys, see if they're activated, and if they are, then we turn on those specific notes. And then, of course, every time there's a change in the actual breath sensor value, we send a volume signal, which is this CC2. And so those 3 different functions are all activated by the breath sensor itself. So let's try and upload that. Let's open the serial monitor. Okay, so now we're getting a full set of readings here. The first one here on the left is the breath sensor value, and then the rest of them are the 16 keys. So let's just see if the sensor still works. It does, and it is correctly mapped from 0 to 127. And then the keys seem to work very well. And these keys here are still touch sensitive, so if I touch one just with the tip of my finger, it gives a very low reading, and then if I cover it with more surface, the reading goes up to 127. So that's very interesting. Now the code that I currently have on here, the Melodica code C, does not use this value for anything. It reads if the key is 0 or non-zero, and from that it decides if the key is pressed down or not. So as soon as you touch the key, the note is on. It doesn't matter to the current code if you press it more or less. And that's fine. Melodicas do not generally have touch sensitive keys. They tend to just have binary on or off keys that you press down, and that's it, and then you control the volume through the tube. But seeing as these keys do have that touch sensitive capability, I really want to try to do a variation on my Melodica code which takes advantage of that. So that brings me to the 4th and final piece of code. Let's have a look at that. Okay, so here in the very last code for the Melodica, the basic change here is that I've introduced this USB MIDI command here, and it introduces a control change or a continuous controller with the number of 113. This is just an arbitrary number within the MIDI continuous controller range, and my idea here is that in Yoshimi I will then simply apply this continuous controller specifically to some kind of filter, which will then go on each voice, so each key individually. Now in order to make that work, I've had to spread these 16 keys out over 16 MIDI channels, so that I can apply the effect separately to each one. So the way that works is that, of course, I was already reading all of these 16 keys in a for loop, and so I simply take this I value here from the for loop, and I turn it into a variable here which I call channel. And so each time I send a note on, I simply make sure to send it to that channel, and so each key has now automatically been assigned a specific MIDI channel separate from all the other keys. So this means that I will be able to hopefully play the keys individually and touch each of them more or less, and then have that filter applied to each key, which will be very interesting but possibly a little hard to play. So I still consider the previous code a standard Melodica code that will do everything that a normal Melodica does, but I really want to try this and experiment with it a little bit and see if it's interesting or if it just drives me crazy. And as far as the printout to serial, it's going to look pretty much exactly the same as the previous one, but let's just upload the code so that we can have a look at it. Okay, so the serial monitor is already open. You can see it's basically the same thing. Breath sensor is there, all the keys individually read from 0 to 127. So no change there, only changes to the MIDI output. Okay, with that I think we're ready to go and open up Yoshimi and make some noise. Let's do it. Okay, so everything is more or less set up and we're almost ready to play here. As usual, I'm running the Yoshimi synthesizer through jack, and I just need to open here and make sure I connect the MIDI ports. For this first test, I have reverted the code on the instrument back to the Melodica code C, which was the one that doesn't use 16 channels, just so we can get a baseline test and see how that works. For those of you who don't actually know how a Melodica works, allow me to demonstrate. First of all, if you only touch the keys, then nothing happens.
Also, if you only blow in the tube, then also nothing happens. But when you combine the two, then you get your sound. Also, by varying the pressure of your breath, you get a variable volume, and so you can articulate and play rhythmically through the use of your breath. Melodicas also are typically polyphonic, which is why I've put this instrument here in Yoshimi into polyphonic playing mode, and so we'll be able to play as many notes as we want. The patch that I'm currently using is one of my open horn patches, the modulator, because the open horn also uses continuous controller number 2 to control volume, and so they're all compatible. So I'm able to pick out any one of my original open horn instruments here and play around with it on the Melodica. So yeah, like I said, as many notes as I want. Okay, so that works quite well and is very interesting. It works basically exactly like a standard melodica, an acoustic melodica. But I still have to try to upload the other bit of code and make all the keys touch sensitive, and then make that work inside Yoshimi with 16 separate channels. So let's try to do that. Okay, so here is the final version of the Melodica code, just like you saw before. Let's try to upload that. Excellent, done uploading. Let's hide this away. Okay, so now in order to make this work in Yoshimi, I actually made a state. This is Yoshimi's way of having presets. So let's just load a recent state, and I have this Melodica state 2 here, which has everything set up to work with the Melodica. Let's call it Melodica 2.0. So that means that I can scroll through these parts here, MIDI parts, and each one of them looks the same. We have the same basic setting here for everything, the same instrument. So that goes all the way up to channel 16, and so you can see there's a channel per key on the Melodica. But just as important is this menu here, the MIDI Learn settings. And here you can see we have 16 separate instances of basically the same thing going on. We have continuous controller number 113 all down this column here, and then depending on what channel it comes in on, between 1 and 16, then we send it to the corresponding part number between 1 and 16. And so now essentially we have 16 separate filters that can be applied to 16 different notes. And the effect that we are applying, the continuous controller number 113.2, is the fantastic dynamic filter within Yoshimi, and I'm using the wah wah preset. So enough chit chat, let's see if that works. Wah wah wah, anticlimax. I was just being really stupid. After re-uploading code to the Teensy, then you have to again connect the two MIDI ports like that. And now we should be working. That's very cool. And it does indeed work separately on each key. That really is very cool, but I have no idea how to play it. I'm not a pianist and I don't play the keyboard very well, and so sure I can find the individual notes and play a chord that makes sense, but this level of individual fingertip control, I'm afraid is completely beyond me. So the next thing that I need to do here, as always, is to record another track for the KontrolFreak theme song. But in order to do that, I am going to revert this back to the previous code so that it will function exactly like an acoustic melodica, and I will be able to deal with it technically and musically, hopefully. And so with that, I think it's time to record some music. Let's do it. Thanks for watching. If you enjoyed the KontrolFreak, then like this video and subscribe to the Continuum Lab channel where I post content like this every week. While you're there, check out the Open Horn MIDI system, my main project here in the lab. See you next time.